Hi everyone, it's Mrs. Mulcahy, and I'm here to help you with your perfect competition practice test answers. Now the problems that we're going to be doing are numbers 5 through 10, 16 through 18, 26 and 27, 29 and 30, 36 and 37, and number 46. What you may want to do is actually do these problems before you sit down and watch the rest of this video to make sure that you have tried them before I give you the answers. Having me just give you the answers isn't really very helpful, but if you're having a problem figuring them out, then the explanation becomes a little more helpful. So let's start off with number 5. So the diagram that you're using with number 5 is this, and this is a variation on lines and boxes. The only problem is that you don't have a Mr. Darp curve for this problem. Instead, you're given a quantity that you're supposed to use. So really, that becomes your anchor line. So the first thing that we're going to do is find the quantity that's identified in the question. And you can see in question 5, it's give you an output at level Q. So that means that we're going to draw our anchor line at level quantity Q. So that means that this becomes our anchor line. So looking at this, we can see that if that becomes our anchor line, and the question 5 asks us about our total variable cost, a box means that we're going to have 4 letters. So where that anchor line crosses average variable cost is at point E, and to make total cost it's going to be a box, so I drew my box in, and it winds up being the letters O, B, E, Q, so that becomes our answer. So on to question number 6. So number 6 is asking us about total fixed cost. So remember, the total fixed cost is going to be a box, but in order to do that, we have to locate average fixed cost on the graph. So average fixed cost is going to be the vertical distance between our average total cost and our average variable cost. So that's this section. So that means that this box becomes our area of total fixed cost. So when I look at that, it is box B, C, D, E. Looking at number 7 now, number 7 is asking us for total cost. So total cost, we're going to do the same thing. We're going to find our anchor line, identify where that average total cost curve crosses the anchor line, and then since it's total, we're going to look for a box. So this would be the box that we're looking for. The only problem is that when we look for box OCDQ, we don't get an OCDQ. But what we do get are these two other options that ask us either OBEQ plus BCDE, which is possible, or OAFQ plus BCDE. Since choice D gives us a kind of a blank in the middle, that's not going to be the total amount of our fixed costs. So the answer to this one is C. All right, so moving on, what we're going to do for this one is we're going to do number 8. So number 8 is asking us about average fixed costs. So average fixed cost is going to be a line. So what we're looking for are 2 letters. So given this one, we know that our average fixed cost is going to be in between our average total cost and average variable cost. So that would be this line segment. But also, there's an average fixed cost curve on this graph as well, so that means that the vertical distance between F and Q counts as it as well. Since they don't give you either a choice of only D and E, I looked to see where it also hit where my other possibilities were, and that's when I realized that it's measured by both QF and ED. Number 9. Now they're asking us about output level Q, and what now we're finding out is they're asking about marginal product, and you have to remember that when you get marginal productivity, sorry about that, productivity and costs are inversely related. So that means that if your costs are falling, that your productivity is decreasing, and vice versa. If your costs are rising, then your productivity is decreasing. So at quantity Q, your marginal cost is rising. So that means that your marginal product, sorry, on this one's actually wrong. It means that our marginal product is falling. Sorry about that. All right, on to number 10. So when we're doing number 10, it's asking us about the vertical distance between average total cost and average variable cost. So vertical distance between these two is really the amount of your average fixed cost. So this is just a funky way of asking you what the average fixed cost is. So average fixed cost each level of output is the vertical distance between ABC and AFC. All right, on to another one. So the next ones that we're doing is number 16 to 18. So this graph is a little bit funky because it's a total data graph, and we haven't really spent much time on a total data graph, which is why I wanted to make sure that I explained it, because I think that this confuses a lot of people that actually look at the practice test. So that's why it looks a little different. Okay, so what we're going to do is we're going to do these in a different order, because I think it's easiest if we figure out what our profit maximizing quantity is, and then it makes more sense for us to do the other two. So we're going to start off with 18, then we're going to go back to 16, and then do 17. That seems like it makes more sense. So let's take a look at this graph. So as you can see, this graph is a little bit funky because it's got a straight line and kind of like a curved line, and they cross each other in 2 points. So really, when you're doing this, you have to understand what's happening on this one. So if we look at number 18, the profit maximizing output for this firm is actually going to be where your total revenue minus total cost is at its greatest. So at its maximum. So you're looking for the biggest vertical distance between the total revenue and total cost curves. So that's where that vertical distance is the greatest. Sorry. So that means that the vertical distance is the greatest between, it's at output 320, because that's the widest point between the two. So then that means that 320 is the output that we really are being concerned with when we come to 16 and 17. Although technically 16 and 17 don't really need you to know this quantity, but I think it's kind of easier if you kind of see the way the graph goes by doing this one first. So let's go back to 16. So this one is just more of a definition of how total fixed cost, total variable cost, and total cost all work together. Now, if you remember, fixed cost plus variable cost is equal to your total cost. And we know that when we have 0 units, we have 0 variable costs. So basically, when your quantity equals 0, any total cost is the fixed cost. So that means that the total cost curve hits our at 0 units at $200. So that means that our total fixed cost for the firm is $200. Now the other thing to know too is that your total cost curve is actually this curve. So because of that, that's what we're looking at when it's talking about the shape of this curve. So since that curve is not completely straight, it means it doesn't go up at a constant rate. It means that those costs are shifting and changing. So when we're doing this one, we have to remember that the costs are falling and rising, and it's caused by productivity. Now, whenever we have productivity, we have to look and see if we're dealing with long run or short run, because that determines what economic concept is going to explain the rising and falling costs. So because it's the short run, it's going to be because of increasing and diminishing costs. Because the economies and diseconomies of scale has to do with the long run. All right, so let's take a look at number 26 and 27. So in 26 and 27, this is just basically a regular short run average cost graph. So in the figure above, at the profit maximizing level of output, what will total revenue be? So what we need to do is we need to basically find where MR equals MC. So that's the quantity where your MR equals MC, which is 20 units. So total revenue formula is price times quantity. If we know that our quantity is 20 and we can see that where our marginal revenue is, we know that marginal revenue and price are the same thing. So that means that our price is $13 times our quantity of 20 gives us an answer of $260. Now with number 27, at the profit maxing level of output, figure out our total fixed cost. We kind of did that a little bit between numbers 5 and 10, but on this one, since we have numbers, we have to actually figure out our dollar amount. So this is our profit maximizing anchor line. We locate the vertical distance between the two curves. Sorry about that. Let's go back and do it again. I hit the wrong button, sorry. So I have to find AFC on my anchor line, and it's this distance right here. And I have to figure this out with the numbers. So I know that to find my AFC, I take my average total cost minus my average variable cost. So the dollar amount of my average total cost is 9. The dollar amount of my average variable cost is 6. So that means that my average fixed cost is $3. Now to find my total fixed cost, I'm going to multiply that times the quantity, and that gives me my total fixed cost. So the $3 average fixed cost times the $20 quantity gives us $60. Now when I look at number 27, $60 isn't one of my choices. So I look at choice E. Choice E says fixed cost is the same at every other level of output. That's just another way of saying that it's constant, which is true about fixed cost. So that's how I know that E is the right answer for number 27. All right, so let's go on to number 29. So for this one, if a firm is in a range of production where it's experiencing economies of scale, knowing that we predict that, well, this one is really understanding kind of the characteristics between short run and long run. So let's take a look at that. So when we look at our short run means that costs are changing due to either increasing marginal returns, and that causes your cost to fall, or diminishing marginal returns, which causes your cost to rise. Now, if you're dealing with the long run situation, your costs are going to change due to economies of scale, which causes your cost to fall, and you also have diseconomies of scale, which causes your costs to rise. So looking at number 29 again, so it's experiencing economies of scale, so I know that that refers to a long run. Okay, now you're also given this weird thing where it seems like it's like you're talking about 10% increases and more than and less than. That's just really looking if you understand what it means if you're doing something efficiently. So we know that this is, if you're experiencing economies of scale, it means that you're becoming more efficient. So that means if you're more efficient, you're getting more out of your resources. So that means that costs are going to decrease and your output will increase. So if you put in 10% more inputs, then that means if you're really efficient, you're getting more out of your inputs than you're putting in. So that means that the change in inputs will change more. So that means that you get a 10% increase in inputs will increase your output by more than 10%. All right, let's look at 30. So 30 is kind of a different variation on this one. So on this one, it says that the firm increases all of its outputs by 10% and output increases by 10%. So you're putting 10% more in and you're getting 10% more out. So you're not being super efficient because you aren't getting more than 10% back, but you're not being inefficient as either because it's not like you're getting less than 10% back. So when you're putting in 10% and getting it back, that's like a constant rate of change. So that means that what we're getting on this one, you're dealing with constant returns to scale. So that means that C is your answer to that one. Okay, this graph. This graph always confuses people, and it's the productivity graph. And part of it is because you really have to think about what these questions are asking you to understand what's going on. So what I've tried to do in these is to highlight what part of the chart it is that we're dealing with, so you can kind of see what it is that it's asking. So let's take a look at the first one. So on the graph above, the onset of diminishing marginal returns occurs beyond. So diminishing marginal returns means that when you add another input, or which is another worker, when does that worker add less than the previous worker? So what we're looking at is we're looking for that high point on the marginal product curve, and then from that high point, marginal productivity starts to decrease. So that's where you're getting diminishing marginal returns. So that means that we're going to find on this graph this high point right here, and that gives us point C, because everything past point C means that we're going to have diminishing marginal returns. Okay, so then we get this question: which of the following statements are true? So obviously when you get a question like this, you have to look each individual statement, figure out which ones are true, and then go from there. So here's our graph again. So the first question says, when total product is at its maximum, marginal product is 0. So let's take a look at where total product is its maximum. So that would be this line that's right here. So looking at that, our marginal product curve is hitting the axis, which means that this is a true statement. So now let's look at the green part. When total product rises, marginal product is rising. So if we look at this part of the graph, this is where our our marginal product is rising, because after point C it starts to diminish. But if you look, the total product curve keeps increasing or going up. It won't start to decline until it hits at point E. So that means that this is actually a false statement. Then let's double check with number 3. When marginal product is greater than average product is rising. Well, that's a true statement, because whenever your marginal is higher than your average, it pulls your average up. So this is a true statement. Then let's look at statement 4. When marginal product is less than average product is falling. So this is a section of marginal product where it is lower than average product, and it's also dragging your average product down. So that is a true statement. So that means that statements 1, 3, and 4 are true, because statement 2 is false. All right, so here comes our last question. So this is really a side-by-side graph question. So according to the graphs above, in which of the following ways the industry supply curve and equilibrium price most likely to change in the long run? So the first thing that we have to do is we have to see what's going on with the firm. So let's find where our marginal revenue equals our marginal cost to figure out if we're making profits or losses. So here is our profit maximizing point. That becomes our anchor line. And since my anchor line does not cross my average total cost curve, I know I'm making a loss. I'm going to extend that anchor line up, and this becomes my area of loss. Now, since all the firms are going to be making a loss, it means that there's going to be a change in the market. Losses drive firms from the market. So that means that we are going to have a correction in the market, and that means that we're going to have a decrease in supply. So our supply would decrease in the market, and then that means that here's our quantity, and here's our price. So that means we have a decrease in supply, and the new price is going to be higher than the original one. So that means that B is your answer. So I hope that helped you to explain some of those answers. If not, then try and ask some questions to your teacher, and good luck on this test.